is extra practice on the chain rule. So like I said, I'll just kind of go through this pretty quickly. I think you guys are getting the handle of the chain rule now. But yeah, they can be a little bit tricky. So the first one, did you guys get y prime equals, you can do the 4 times 10 and have 40, and then x squared minus x, or x squared plus x minus 1 to the 9, and then we multiply by the derivative of what's inside, and the derivative of what's inside is 2x plus 1. Did you guys get that? If you want to simplify it a little bit, you could multiply the 40 and the 2x plus 1, but I would never FOIL out that junk raised to the 9th power. That would take you a very long time, so don't do that, okay? So the next one, I would rewrite as -1 and then x squared minus 5x minus 6 to the -2. If you didn't, it's fine. You just probably use the quotient rule. So when we do this, we get -1 times -2 is 2. We have the stuff on the inside. That's our u. Raised to the -3, right? Subtract 1 from the power. And then times the derivative of the inside, which should be 2x minus 5. Did everybody get that? All right, looking good. All right, so the next one, we have -5 and then 4 minus 9x to the 3 over 2. So we're going to do y prime equals -5 and then times 3x. So I'm going to have -15 over 2. And then I'm going to have 4 minus 9x. And I subtract 1 from the power. So what do I get? Yeah, 1 over 2, exactly. And then times the chain, which is -9. All right, this next one, I'm going to do the quotient rule. So I have y prime equals low d high, the derivative of high is 2, minus high, 2x. D low is going to be 3, 4x cubed minus 5x plus 1 squared times the chain. I don't have room, double-decker numerator. So times 12x squared minus 5 all over the square of what's below.
Wait, sorry, can you
you also just use the chain rule?
You could. Chain rule and product rule though, right? If you brought it up. So if you rewrote as 2x and then 4x cubed minus 5x plus 1 cubed, or to the -3, you would have to do the product rule with these two pieces of the product. Right. So you could do that.
can just leave it like that?
Yeah, there's not much simplifying you can do. Actually, there is a little bit that I think I would expect you guys to do, and this will come into play later when we find like where the tangent line is horizontal. What did I do? Did I do something wrong? Nope, because you're going to square it. So like x cubed times x cubed would be x to the 6th. Yep. All right, so one thing that as you're finding the equation of tangent lines and so on, you'll have to simplify a lot of things that involve the chain rule with the quotient rule. And looking at this numerator, do you guys see how you have like a common factor? You have 2 of those in common on the numerator. So really what you could do is you could pull that out to the front and you could say, oh, I have 4x cubed minus 5x plus 1 squared. And then inside of a big bracket, I have what's left. So I have 2 times 4x cubed minus 5x plus 1. Do you guys see that? And then minus 2x times 3. So all of that was the numerator, which would then be much easier to simplify, right? All over the 4x cubed minus 5x plus 1 to the 6th. So Michaela had a confused face. So you could use the chain. Well, I used the chain rule right here. So I did 3 times the thing squared times the chain like that. Oh, I left off my 12x squared minus 5, didn't I? Is that what you're going to tell me? Yeah, but I left it off on this one. So times 12x squared minus 5 right there.
So all of this is just like after you simplified it?
That would be a way to simplify. And then do you guys see how you have squared on the top and then 6th on the bottom, then that would become 4, and that would go away completely.
So we can't leave it like this.
I'm just saying eventually you're going to have to do things where you have to like solve this. You have to factor the numerator, factor the denominator, and that's a trick that you would do. Yeah, AD.
So if you did it using the chain rule and the product, would it potentially look different?
It will look different, but they would end up simplifying to the same thing. So like this one would simplify, let's see, 8x cubed minus 10x plus 2. And then I have minus 6x that I multiply in, so minus 72x cubed plus, let's see, 6x times 5, so plus 30x, all over all of that to the 4th. And then you would just combine your like terms. So you would say, let's see, 8 minus 72. So what is that? Negative 64. X cubed plus 20x plus 2 all over the 4x cubed minus 5x plus 1. So basically you would do this a lot when you are graphing an equation. So we're going to have like crazy functions that we're going to learn how to find the maximums and minimums of. And so this would be an instance where if you were trying to set the numerator equal to 0, you would have to simplify that numerator. So that's the way you would do something that involves the chain rule. Yeah?
So if we just did that initial first step, would we wrong?
Like, are you saying with the chain, like with the product rule instead?
No, I'm saying if we just did that.
Oh yeah, that's fine. Yeah, and I'll specify whether or not you need to simplify if it's on the test. All right, so let's see the next one. So we have y equals 2 over 2 minus x squared. So you could do a couple different things here. So I think one of the easiest things to do would be to go ahead and like simplify it first, like bring the square in. That way you don't have to do like the quotient rule for the chain part as well. So if you multiply this out, you would have 4 over, and then the bottom becomes that 2 minus x squared, which you can leave it like that. And then I would probably just rewrite so I can use the chain rule, like raise it to the negative 2. So that would be a very quick way of finding the derivative. So now y prime would be negative 8, 2 minus x to the negative 3, and then times the negative 1. So this one is one that's very easy to simplify, so something like this I would definitely expect you to simplify. So you can write it as 8, 2 minus x to the negative 3, or you can say 8 over 2 minus x to the positive 3. Either way. All right, makes sense? So same thing on the next one, you could bring that up as a negative 2, but then you would still need to do the product rule. So when I have a decision like that, when I'm like, oh, I would still have the product rule and the chain rule, I just leave it and do the quotient rule. Like I don't typically like bring it up and use the chain rule, or and use the product rule. Maury does every single time though. Do you guys know that? Maury hates the quotient rule because he can't remember if it's low-d high or high-d low. So he always does that. Yeah. So we're going to do low, d high is 4, minus high is 4x. D low is going to be 2, x plus 1 to the 1, and then times 1, right? All over the square of what's below, so it's x plus 1 to the 4th. So do you guys see whenever you do this quotient and chain rule situation, like you're going to have that thing that you have in common, right? So the quickest way to simplify something that looks like this is to pull out the GCF. So this one has a couple things in common. You could pull out a 4 and an x plus 1.
So
Yeah.
you did do the chain rule there, right?
Yeah, I did the chain. It was raise the 1 and then times 1. Yeah. So if I pulled out the x plus 1 and I also pulled out a 4, then inside my brackets, I would have a 1 as a placeholder. I pulled out a 4 and the x plus 1. So what do I have? 2x it looks like, right? So I'm going to have 1 plus 2x. Do you guys see how I did that?
Well, how can you pull out? How would it be plus 2x?
Oh, minus 2x? Yeah, it is minus 2x. Thank you, Ariana. Minus 2x, because there's the 2 there.
Okay.
Yep. And then the convenience of that is that if I was setting the numerator equal to 0, I have it factored. Do you guys see that?
Where'd the 2x come from?
Okay, so the common factor is a 4 and an x plus 1. So a 4 and an x plus 1, so it's what's left, the 2x there. All right, so it's nice because it's all factored. Yeah, it was right. Oh, you are right. Thank you. Man, I'm really messing this one up. All right, x plus 1, and then minus 2x. Is that right? Yeah. So you see what Abby's saying. There is an extra x plus 1. All right, so I'm going to have 4 times, the x plus 1s are going to cancel on the top and the bottom, but I have a 4th. So, you guys are killing me. All right, I think I'm good. Pretty sure I'm good right now. I don't know what the negative 4x is that you're talking about.
When you pull out a 4 and then pull an x plus 1, shouldn't you have an x in there still? A negative x?
I do. But there's a 2 with it, so negative 2x. Yeah. All right, so I'm going to have 4, and then I'm going to have x plus 1 cubed, and then on the top I have negative x plus 1, like that. Do you guys see what I did? So I just canceled one of the x plus 1s, so I had 3, and then I simplified the x plus 1 minus 2x. So like I was saying, eventually we're going to do that a lot because we're going to have to factor the numerator in order to find when it's equal to 0. So just kind of previewing that. All right, and then number 7. So number 7, same kind of stuff. So we're going to have cosine of 3x, and we're going to square it. So I have y prime equals, and I'm going to do 2 cosine of 3x raised to the first times the derivative of cosine of 3x is negative sine of 3x. Anything else? Yep, times 3, good. So it'd just be like negative 6 cosine of 3x sine of 3x. And you can put parentheses around the 3x or you can leave it. All right, so the first thing that we had, this was our u, so it was in the form u squared. So its derivative is 2 and then u. Oops, I underlined too much. 2 and then u, right? And then this is the derivative of u. So it's like you're setting up a second problem and you're saying, well, what if u was cosine of 3x? Then what's the derivative of u, you know? So it'd be negative sine of 3x times 3. So you're doing like 2 problems in one, basically. It comes from the derivative of 3x. Yeah, because if you're taking this as your u, so if I rewrite an equation and I'm like, okay, u is cosine of 3x, then when I find its derivative, it would be negative sine of 3x, right? Because this is in the form cosine of u. So negative sine of u times du. Okay. All right, we feeling okay about this stuff? Yeah? Let's skip over 8. All right, so this one would involve a chain kind of in the middle of the problem. All right, I think number 10 looks pretty hard. 10 is actually very, very hard. So do you guys see it's like multiple u substitutions? So it's it's a 2, it's a w. So we treat that as our u. So we have 4u cubed. So how do I take the derivative of 4u cubed? It'd be 12u squared, right? So we're going to have 12, the u part squared, and then times the derivative of u. So our u is this whole inside part. So we have 1/2 5x minus 4 to the 5th minus 2x. So now it's like you're setting up a second problem and you're saying, well, what if I had 1/2 5x minus 4 to the 5th minus 2x? How would I take the derivative of that, right? That's what's going to go under the du. So we're going to have 5 over 2, 5x minus 4 to the 4 times 5 minus 2. Because the derivative of 2x is 2. So do you guys see that this derivative would be 5 over 2, 5x minus 4 to the 4th times the chain was 5 and then minus 2. Yeah, tricky. We won't simplify that one. That would be a lot to handle. We'll leave it. All right, are you guys kind of understanding this? All right, and then obviously you can ask questions where it says find the equation of the tangent line, blah, 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 right? So if I'm finding the equation of the tangent line, I'm going to do y prime, and I have a product rule. Do you guys all recognize that this involves the product rule and the chain rule? Okay, the nice thing is x is equal to 0, so you'll see some magic happen. A lot of things will go away. So we're going to do first is 2x plus 4 cubed times derivative of the second is 4 times x cubed minus 1 cubed times 3x squared, right, the chain. So that was the derivative of the inside. Plus derivative of the first one, so the derivative of 2x plus 4 all raised to the 3 is going to be 3 2x plus 4 squared times the chain, which is 2. And then times the other one normal is x cubed minus 1 to the 4th. Pen, did you go to Candyland in the middle of class? You just couldn't stand it, could you? Yes.
Okay, so you have like the 2x plus 4 to the 3rd, but where did the 4, like times 4?
2x plus 4 to the 3rd times, it comes from the derivative of the next one. So let me circle the pieces. So this is the derivative of the, or that's the first one normal, right?
Oh, so you're doing
This is the derivative of the second, right? And then this one is the derivative of the first one. Oops, I left off my 2. derivative of the first one, and then that one's the other one normal. All right, so what I always tell people is don't even try to simplify this in if you have an x value. So we're just trying to find the slope at x equals 0, right? So why would you waste time like trying to multiply that out? Please don't. Did you guys see that we just plug in x equals 0? So when we plug in x equals 0, we get 4 cubed times 4 times negative 1 cubed times 3. Oh, 0 squared. That's exciting. That all goes away. Plus 3 times 4 squared times 2 times negative 1 to the 4th. So this whole first part is gone. You get it? And the second part is going to be negative 1 to the 4th is 1, 4 squared is 16, so I have 3 times 16 times 2 times 1. Anybody know what that is? It's 96. So your slope is 96. Now we're finding the equation of the tangent line, so we also need to remember that we need a point, 0, comma something. So we don't go into our slope equation, right? We go back to the original. So we've done plenty of these. So when I plug in 0 into the original, y of 0, I get 4 cubed times negative 1 to the 4th, which is positive 64, which is a y-intercept, 0, comma 64. So you can just write it in y equals mx plus b if you want. So it's y equals 96x plus 64. All right. Okay, we'll do one more. All right, so find the slope for y equals 2 cosecant squared of pi x over 12 at x equals 3.
How
So
do you go into, like, would it use the point slope?
This was a y-intercept, so it was easier to use that y equals mx plus b. I mean, I could easily do y minus 64 equals 96 times x minus 0, but we don't need to do that, right? We have the y-intercept. All right, so let's rewrite the y as 2, and then in parentheses, cosecant of pi x over 12, quantity squared. All right, so this is in the form 2u squared. So the derivative of 2u squared is 4u, and then we do times derivative of u, right? So we're going to have 4 cosecant of pi x over 12, and then times the derivative of u. So remember what I was saying. You're just thinking of this as a brand new problem. You're like, well, what if y was equal to cosecant of pi x over 12? How would I take the derivative? So now it would be in the form cosecant of u. Do you see it? So do you guys remember the derivative of cosecant?
Cosecant, cotangent?
Close, but there's a negative, right? So it's going to be negative cosecant pi x over 12 times cotangent of pi x over 12 times the chain. What is the derivative of pi x over 12? Pi over 12, right? It's just a coefficient. That's all it is. So that's our derivative of u.
So the derivative of cosecant is just negative.
The derivative of cosecant is negative cosecant x cotangent x. Okay, now be careful though, because a lot of you guys have been writing that on your homework. You're just leaving it as x. So put whatever your u value was.
So why'd you
We call that
just-
the argument. It's the pi x over 12 stays in it throughout.
you put the cotangent?
Oh, I put cosine, didn't I? That should be cotangent. Thank you. I was busy writing everything else. All right, so then we would plug in 3. So you can use your calculator to help you. These are all values that you know. Like cosecant of pi x over 12 is going to be, when I plug in 3, it's going to be pi over 4. So what is the sine of pi over 4? Root 2 over 2. So if we do the reciprocal of root 2 over 2, do you guys know what the reciprocal of root 2 over 2 is? So it's it would be 2 over root 2, but that actually reduces down. It's kind of a good one to know, to just root 2, which seems weird, right? 2 over root 2 is really just root 2. Yeah, but it's root 2. So this first part is going to be root 2. All right, and then we're going to have times negative, again, negative cosecant of pi over 4, right, which is still root 2. What would cotangent of pi over 4 be? Cotangent? What's tangent of pi over 4? 1. So what's cotangent? 1, right? And then times pi over 12. So we would get, let's see, the 4, and then this negative root 2 over 2 times root 2 over 2 is going to be negative 2. So we're going to get 4 times negative 2 is negative 8 times pi over 12. So we would get negative, if we divide by 4, negative 2 pi over 3. Yeah, that's the slope. Yeah, Beth, do you have a question? It's the chain from this portion. So just like if you had like 5x, its derivative is 5. If you have pi over 12x, that's what it was, pi x over 12. Its derivative is pi over 12. Because it's a double chain. So if you think about, so this was our u, right? If you think about that as being a separate problem and you're like, okay, u is equal to pi x over 12, then its derivative, du, would be, yeah, you would do negative cosecant of u times cotangent of whatever your u is. I keep on writing cosine. And then times the derivative of u there. So it's kind of confusing. Maybe I should make this a w times its derivative. So the derivative of the w was pi over 12. Yeah. An equation you would have to like plug in pi over 3 to find a point, but it's just asking for the slope of this one. So you're done. All right, so I'm going to skip the chart problem because that's actually on your homework. So I'm going to leave that off.